and welcome to all my young friends who are studying in intermediate and they are watching this video. Welcome to Calculus Made Easy series. The aim of this series is to make calculus simple, interesting, and easy to understand. So let's have a recap of what we have learned till now before we start. We are dealing with the topic of limits. We learned methods of finding limit, that is substitution, factorization, rationalization, then limits at infinity of rational functions, where we had three cases. When degree of numerator is equal to degree of denominator, at that time limit is equal to ratio of leading coefficients. When degree of numerator is less than degree of denominator, at that time limit is 0. When degree of numerator is greater than degree of denominator, then a limit tends to either positive infinity or negative infinity. After that, we discuss very important limit in a form of a theorem, that is x raised to the power n minus a raised to the power n upon x minus a, limit x tending to a, which is equal to n minus 1. And then we discuss right and left limits. I hope that you must have seen these videos. If you have not seen these videos, please do see that. Now today we are going to discuss a very important theorem, but before that let us discuss one more theorem, which is a prerequisite for understanding that theorem which we are going to discuss shortly. Now the theorem says that let f and g be two real value function with the same domain. They have the same domain such that fx is always less than gx for all x in the domain. So what is being told here, that there are two functions f and g, or we can write fx and gx also. That's more or less the same. Fx is always less than gx for all x in the domain. So now the theorem says, now if you draw the graph, it can be like this, that gx is always higher. You can have any type of graphs. You can have gx like this and fx like this, gx like this and fx like this. It can be any shape, not necessarily this shape. This is just to show you. So what is being told, that for some value of x, that is a, if both the limits fx and gx exist, means the limits of both the functions fx and gx exist at x is equal to a, then, now say this is a, then the limit of fx will be less than the limit of gx. I hope this is very simple. It should be clear. The only thing is that what is being told, the limit should exist. It may be that fx is less than gx, but the limit may not exist. It can be like this, what we discuss in the right limit and left limit. It can be like this. The curve of gx can be like this. So here the limit of fx does not exist, or gx also can be, say at x is equal to, it can be like this. There is a gap. So the limit will not exist in that case. But what is being told, that the limit exists for both the function at x is equal to a. Then if fx is always less than or equal to gx, then the limit of fx at x is equal to a will also be less than the limit of gx. It's a pretty simple thing, and I hope that you all must have understood this. Let's proceed further. Now we are going to discuss sandwich theorem or squeeze theorem. I think you all must have uh, eaten sandwich, so I need not explain what is sandwich. But the sandwich word, you know, means something which is between two things, two objects. It is in between those two objects. So then it is called sandwich in the narrow space between two objects. Now, why do we call this as a sandwich? Because you can see this some material, tomatoes, lettuce, cheese, which is sandwiched between two slices of bread. That is the reason we call it sandwich. So, what does this sandwich theorem means? We also call it squeeze theorem, right? Before that, let me also give one more example. Suppose there are three brothers, eldest, middle, and the youngest. Now, if the age of eldest is A, E, and age of middle is A, M, and age of youngest is A, Y. So obviously, A, E will be greater than or equal to A, middle will always be greater than or equal to A, youngest. Means the age of the youngest will be the least and age of eldest will be the highest. Why I have put equality sign here? Because if they are twins all born at the same time. Now, if I say that age of youngest and age of eldest is equal, means age of eldest is equal to age of youngest. This indicates that age, and this is equal to say something like x. This will indicate age of middle will also be equal to x because middle is sandwiched between eldest and youngest, right? Now, in case the ages of eldest and youngest are same, that means that in fact indicates that they are all twins. So middle one will also have the same age. I hope that this example is clear to you, and also the earlier example of sandwich is clear. Now let's proceed to the theorem. Sandwich theorem. Sandwich theorem says that f, g, h be real functions such that fx is less than or equal to gx is less than or equal to hx for all x in the common domain. They have a common domain. So the hx is greater than gx and gx is greater than fx. Now, their graph can be like this. It's not necessary they'll be they have to have this shape. They can be something like this, something like so. It can be anything. It can be of any other shape. It's not necessarily what I have shown here. I've just shown here uh, for a good depiction so that it is easy for you to understand. So their graph can be like this. Now, if for some real number a, that is some real number, limit of fx, which is the least, is equal to limit of hx, which is the greatest, and both this limit is equal to L. Now the same example which we discussed of three brothers, if the ages of eldest and the youngest are equal, then the age of middle will also be equal to that. Here also apply the same logic. If the limit of fx, what is fx? Fx is the smallest function, is equal to the limit of the greatest function, which is hx, and both are equal to L at some point A. What does that mean? It means that now gx is perfectly sandwiched between y and fx. Then the limit of gx is also equal to L. This is pretty simple, and I hope that whatever I have explained is clear to you. This theorem, please note that this theorem is very useful in finding tricky trigonometric limits. And we'll just demonstrate by good examples. What do we mean by that? However, before we attempt questions, let's refresh our knowledge on inequalities. You all must have read about equations. Equation is represented by a symbol equal to. In an equation, we can add, subtract, multiply, or divide on both sides. For example, A plus B is equal to C plus D. This is an equation. Take a very simple equation, x is equal to 5. This is an equation. You can add anything, means x plus 5 is equal to 5 plus 5 is equal to 10. You can subtract anything, x minus 2 is equal to 5 minus 2 to 3. You can multiply by anything, 2x is equal to 5 into 2 is equal to 10. You can divide by anything. In fact, division is a form of multiplication only. X upon 3 is equal to 5 upon 3, right? Or 1 upon x is equal to 1 upon 5. So all these kinds of operations are possible in case of equations. However, in case of inequalities, which are represented by these kind of symbols, greater than or equal to, less than or less than or equal to, in these cases we can add, subtract on both sides, no problem. However, we cannot multiply or divide on both sides until and unless we are sure about the thing by which we are multiplying. Means it has to be positive, then only we can multiply. I'll just demonstrate by some example. For example, 4 is greater than 3. But if you multiply by minus 1, minus 4 is less than minus 3. Right? 10 is greater than 5 is greater than 2. Multiply by minus 1, minus 10 is less than minus 5 is less than 2. So if you multiply by negative in case of inequality, then the inequality gets reversed. The sign of the inequality gets reversed. So these are some of the examples. So we have to be very sure about the thing by which we are multiplying. One more thing, if A is greater than B, then 1 upon A is less than 1 upon B. Very simple. 4 is greater than 2, but 1 upon 4 is less than 1 upon 2. I think this is sufficient for you. This much inputs about inequalities are sufficient in order to tackle the problems which we are going to deal with. Now let's solve some questions on sandwich theorem so that we have a fair idea as to how to solve the questions based on sandwich theorem. The first question is limit x tending to 0, x square sine 1 upon x. Now we have to use sandwich theorem to find the limit in this case. See, whenever you do any question based on sandwich theorem, you have to see whether there is something which can be conver- converted into an inequality. Like here we have trigonometric functions here. Now we all know that sine x or cos x, they always lie between -1 and +1. So we can take the help of this property and use sandwich theorem. I'll just show you how. You have sine 1 upon x will always lie between -1 and +1, right? That means now you can, if you multiply it by x square on all the sides, so this will always lie between. Now you may ask a question that we have multiplied by x square, is it okay? See, we are multiplying by x square. Whatever the sign of x may be, x square will always be positive. Now put the limits on all three sides. Limit x tending to 0 minus x square, limit x tending to 0 x square sine 1 upon x, limit x tending to 0 x square. Now we have to find this limit. This is our question. But by sandwich theorem, if we are able to find both these limits and if they are equal, so the limit of the middle function will also be same. Now this limit x tending to 0 minus x square will be 0, and here also it will be 0 because you have to just put the value here. It's a method of substitution. That means limit x tending to 0 x square sine 1 upon x, it lies between 0 and 0, sandwiched between 0 and 0. That means this limit is also equal to 0. So that's the answer. Here we have to find the limit x tending to infinity, x plus 7 sine x upon 13 minus 2x. Here we have trigonometric function, that is sine x. So we'll take the help of the property of sine x, that is sine x will always be greater than or equal to -1 and less than or equal to +1. Now we have 7 sine x, you multiply by 7, so here also 7 and here also 7, and we have x also here, so just add x here. So we can add anything in inequality. I already told you there is no problem. Now we have to divide by 13 minus 2x. So what we'll do, just divide x minus 7, 13 minus 2x, x plus 7 sine x upon 13 minus 2x, x plus 7 upon 13 minus 2x. Now what about this 13 minus 2x? 13 minus 2x, because we are dividing by 13 minus 2x, so we have to be sure what is its sign. Now, as x tends to infinity, 13 minus 2x tends to 13 minus 2 into infinity means infinity, means it tends to minus infinity, that is negative. So since it is negative, the inequality will be reversed, but it doesn't uh, matter anything here. Now we have to apply limits. Limit x tending to infinity, limit x tending to infinity, limit x tending to infinity. Now in between we have the limit which is in question, so we don't have to do anything for this. We only have to find the limits of this as well as this, and if they are equal, that means the limit of the middle function is also the same. Now limit x tending to infinity, x minus 7 upon 13 minus 2x. This will be limit x tending to infinity. You take x as common, 1 minus 7 upon x, x 13 upon x minus 2. X will get cancelled, and when you will put x as infinity, this will become 0 and this will also become 0. So this will be minus 1 upon 2. We have already told that when degree of numerator and denominator is equal, then the limit is the ratio of leading coefficients, that is 1 and minus 2. So this limit is comes to minus 1 upon 2. Similarly, limit x plus 7 upon 13 minus 2x, x tends to infinity. This also will be minus 1 upon 2. So this limit also is minus 1 upon 2. That means minus 1 upon 2 limit x plus 7 sin x upon 13 minus 2x, x tending to infinity, lies between minus half and plus half. That means this limit is minus half. So that's the answer. The third question, we have a function fx sandwiched between 9 minus x square and 9 plus x square, and we are supposed to find the limit at x is equal to 0. Now what we'll do is 9 minus x square fx 9 plus x square. Simply just put the limit x tending to 0, limit x tending to 0, limit x tending to 0. Now the right hand function will, here the limit will be 9, because once you put the value of x as 0, it will become 9, and this will also be 9. That means limit x tending to 0 fx 9. So this implies that limit x tending to 0 fx is equal to 9. So that's the answer. The next question is limit x tending to infinity bracket x upon x. Now what do we mean by bracket x here? This bracket x means fractional part of x. But we don't have any trigonometric function. What do we do? So just think over that, pause the video and think yourself what we can do here. I think some of you might have got a clue. The property of this bracket x is, it always lies between 0 and 1. I have explained this fractional part and greatest integer and mod in one of my earlier videos. If you have not seen that, please do see that before attempting this question. I have already put the link of that in my description box. Now what we will do, multiply or divide by x. 0 upon x, bracket x upon x, 1 upon x. Now you will ask me, okay, we are dividing by x. Will the inequality not be reversed? No, because x is tending to infinity.